So another way is, so right now Clicky can agentically kind of follow along with my questions. It's not only point and click. Since the Claude SDK is now in play, I can go ahead and kind of reason with literally everything. I like to call it the vibe coding everything, or just Claude code for everything. So let's test this out, right? So hey Clicky, can you analyze this video, see what's going on, and then just maybe point out some cool things that you see to teach me about higher order derivatives.
Okay, so this is the higher order derivatives chapter. The curve is f of x, curving upward. Here you've got two
You see how I did
stacked
the second
nudges,
point and then the selecting?
df1 and df2. Each one is a higher derivative order. df2 is the change in the change, how fast the slope itself
Full
is
annotation
accelerating.
all
That's
over
the
your
second
screen.
derivative.
And it can also click
Let
and
me
interact.
play a few seconds and see what the animation shows next.
See, now it's going to continue the video.
The difference between these changes, the change in...
A zoomed-in box just appeared on the right side of the screen. It's zooming into df1 and df2 side by side, so you can really see the size difference between them. The key insight, df2 is much smaller than
Isn't that so
df1.
cool? It's like guiding me.
As dx shrinks,
it's like right there, like
df2 shrinks
walking me
way
through the
faster,
entire thing.
Proportional
While
to
another
dx
video
squared.
is. Maybe I have a question
That
that's like very
ratio,
deep. Yeah.
df2 over dx squared, is what the second derivative actually is. Want me to keep watching?
Yeah, let's keep watching.
How the function changes is what we'll call ddf.
Now we see d of df, the change in the change. That label is pointing at the difference between df1 and df2. df2 minus df1 is the second derivative. It's how much the slope sped up or slowed down over one tiny dx step. And on the curve itself, df1 and df2 are these two stacked yellow brackets, one taller than the other because the slope is growing. The gap between those two brackets, divided by dx squared, is exactly what the second derivative notation, d squared f over dx squared, means.